Today we are starting with Reactivity 3, proton transfer reactions, which is a fancy way of saying acids and bases. So we are going to be starting off by defining a few key terms, then we're going to identify some Brønsted-Lowry acids and bases, and then finally we're going to look at a few classic acid reactions. But before we start, you can download this very PDF of this document so you can be making your own revision notes as we go through. So let's start with why we are here, Brønsted and Lowry. So they came up with a really good definition of acids and bases, which works well for lots of different reactions, including reactions that don't take place in water. So the Brønsted-Lowry model states that an acid is a proton donor and a base is a proton acceptor. So an acid has to have a proton that it is willing to lose, and then yet a base has to have some space to be able to accept it. So you can think of acids as givers and bases as takers. So we'll look at this in more detail in a bit, but for now, onto a few more definitions. So first up is an alkali. So this is a soluble base, which when dissolved in water produces the hydroxide ion. So we've got our example here. So sodium hydroxide, is a solid, but when you dissolve it in water, you end up with two ions, so the sodium ion and the hydroxide ion. But just remember that not everything with OH is an alkali. So for example, here we've got methanol, which is an alcohol, and alcohols also contain OH, but they behave and react in very different ways. Okay, on to dissociation. So this is when a compound splits up into the ions that make it up when it is in a solution. So sodium hydroxide is an example of that. Okay, now on to a salt. So a salt is an ionic compound formed from an acid and base reaction, and more on salts later. And finally, we've got some different types of acids. So we've got monoprotic acids. So these are acids which contain only one acidic hydrogen. And diprotic acids are an acid that contain two acidic hydrogens. So acidic meaning it is willing to donate them. All right. So now let's have a go at identifying some Brønsted-Lowry acid and bases. So we're going to go through this row by row. So our first row here are all acids, and they're all inorganic acids. So they're all acids because they've got some hydrogens to donate. So we've got a couple of monoprotic acids, and then this is a diprotic acid, and then you can even have acids that can donate 3 protons. Happy days. Now on to some alkalis. So these are alkalis because when they dissolve in solution, you're going to get the hydroxide ion. Okay, on to our next row. So these are some organic acids. So organic acids are, they contain carbon, and they also contain hydrogens that can't be donated. So with these, we've only, so we've got a carboxylic acid here, which can donate this hydrogen, and this will be an aldehyde which can potentially donate this hydrogen. And then finally we have some bases. So these are bases because they do not produce the OH ion when dissolved in water, if they do dissolve in water. So ammonia dissolves in water, but these two bases do not, but they do react with acids, and they are, all three of them are capable of accepting a hydrogen ion. Okay, now on to some must-know acid equations. So we're going to go through some classic acid reactions. So this is not mentioned in your syllabus, but it is expected knowledge, and depending on how much chemistry you've done before the IB program, you might have missed this. So it's always good to just have a quick recap, just to get the confidence up and running. So the first one, the absolute classic, the neutralization reaction. So with this, we have an acid is reacting with a base, which gives us a salt. and water. So yeah, so going back to salts, as I said, we'll talk more about them later. Well, now is the time. Yeah, so salts contain, yeah, the metal part, and the metal part always comes, yeah, from the base, and a non-metal part, which always comes from the acid. So there we go. So we've got our general equation, and then, yeah, this is a specific equation. Okay, on to the next one. So in this next one, yeah, this is an acid, yeah, reacting with a metal. So again, we've got the acid because it can donate a proton, a metal. So not all metals, it has to be a reasonably reactive metal. So some metals don't react with acids, but yeah, we've got magnesium, which is pretty reactive. Then again, we are getting a salt, and this time we are getting hydrogen. So yeah, a quick look at the salt again. So we've got the metal, so the metal part, and a non-metal part. And again, we can see the non-metal part is coming from that acid. Okay, on to our next example. So this is, yeah, an acid reacting with either a carbonate or a hydrogen carbonate. So yeah, so the carbonate ion is this, which is, yeah, slightly different to the hydrogen carbonate ion, but the equation is the same in terms of what is produced. So with this, again, yeah, we've got an acid reacting with the metal carbonate, and again, we're getting a salt, water, and yeah, carbon dioxide. So it doesn't matter if it's the metal carbonate or the metal hydrogen carbonate, we're going to get these three products. Okay, and now finally, we have an equation to do with the bases. So yeah, so bases react with ammonium salts. So we've got a base reacting with an ammonium salt. Yeah, so ammonium is this, so yeah, the ammonium ion is NH4+. And again, we're getting another salt. We're getting some water, and we are getting ammonia. So if you want to make ammonia in the lab, then this is the equation to do it. So sometimes you might not have ammonia lying around, but you might have a base and an ammonium salt. And yeah, this is the way to get some ammonia if you need it. Okay, so yeah, so with all of these equations, you are, yeah, making a salt. And yeah, getting the correct formula for the salt is very, very important, because if you get this wrong, then the equation won't balance. So this is what I'm talking about, is making sure, yeah, like these little numbers, you're getting the right little numbers. And yeah, if you need a little bit more help with writing formulas or equations in general, then check out my website. The link is in the description, and on the website you can find out about tutoring and how to get in contact if you do, yeah, need a bit more help. And okay, there we go, that's everything. So thank you for watching, and if you want more IB chemistry content, then please do like and subscribe. It would mean so much to me. All right, thank you, and catch you in the next one. Ciao.